How catalysts speed up chemical reactions. Catalysts are an essential part of chemical reactions. They have the remarkable property of accelerating reactions without being consumed in the process. A catalyst is defined as any substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. Catalysts expedite the process by lowering the activation energy of the reaction, which is the energy required to start the reaction. The concept of catalysis has been known since ancient times. The first well-documented use of catalysts was in the 19th century, by Humphrey Davy, who used platinum as a catalyst for the oxidation of hydrogen and carbon monoxide. Catalysts play a vital role in the modern chemical industry and are used in various chemical processes, including the production of fertilizers, pharmaceuticals, and petroleum products. The chemical industry relies heavily on catalysts to increase the rate of chemical reactions, reduce the costs of production, and minimize environmental impact. Types of catalysts. There are two main types of catalysts: heterogeneous and homogeneous. Heterogeneous catalysts are catalysts that are in a different phase, solid, liquid, or gas, than the reactants. For example, in the catalytic converter of an automobile, the catalyst, typically platinum, palladium, or rhodium, is a solid, while the reactants, exhaust gases, are in the gaseous phase. Homogeneous catalysts, on the other hand, are in the same phase as the reactants. For instance, enzymes in the human body act as homogeneous catalysts and are essential for the functioning of our metabolism. Mechanism of catalysis. In order to understand how catalysts work, it is important to have a basic understanding of chemical reactions. In a chemical reaction, the reactants are transformed into products by breaking and forming chemical bonds. The energy required to break the bonds of the reactants and form the bonds of the products is called the activation energy. The activation energy is the minimum amount of energy required for a reaction to occur. In other words, it is the energy that has to be supplied to the reactants in order to initiate the reaction. Catalysts work by providing a lower energy pathway for the reaction to proceed. Essentially, they lower the activation energy required for the reaction to start. To understand how this works, it is necessary to review the energy diagram of a chemical reaction. On an energy diagram, the starting point of a reaction, reactants, is on the left side and the endpoint, products, is on the right side. When a catalyst is present, it provides an alternate pathway for the reaction to proceed with a lower activation energy. In other words, the catalyst lowers the energy of the transition state, as shown in Figure 1. Energy diagram of an uncatalyzed reaction, red line, and a catalyzed reaction, blue line, indicating the reduction in activation energy provided by the catalyst. As a result of this lower activation energy, more reactant molecules have sufficient energy to overcome the energy barrier and react. The catalyst does not participate in the reaction itself, but rather speeds it up by providing an alternate pathway for the reaction to proceed. Catalysts and equilibrium. Catalysts do not alter the equilibrium of a reaction since they do not affect the thermodynamics of a reaction. The thermodynamics of a reaction, which is determined by the change in Gibbs free energy, delta G, determines whether a reaction will occur spontaneously, delta G less than 0, or not, delta G greater than 0. Catalysts merely speed up the rate at which equilibrium is attained, i.e., they alter the kinetics of the reaction, but they do not alter the position of the equilibrium. Types of reactions catalyzed. Catalysts can be used to accelerate many types of reactions, including 1. Acid-base reactions. 2. Redox reactions. 3. Polymerization reactions. 4. Enzymatic reactions. Acid-base reactions involve the transfer of protons from a donor to an acceptor, resulting in the formation of a new compound.